Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to implement an array data structure. We're going to build the array using an object, and specifically, it's going to be a dynamic array, which means it won't have a fixed size and can grow as large as we want it to. The methods we're going to add are get, push, pop, insert, and remove. The operations at the end of the array, push and pop, should happen in O of 1 constant time. And whenever you access an item at its index, this should also happen in constant time. We're going to maintain the length of the array ourselves inside of our object. And also, we're going to need to manage all the indexes. This means whenever we add or remove an item, we also must update the indexes of the array itself. So we're going to create a class called dynamic array. It's going to have a standard length attribute, which just returns the number of items in the array. And then we're going to store the data in a hash table. The methods we'll add are get, that accesses an item at its index, push, which adds an item to the end, pop, which removes an item from the end, insert, which allows you to add an item at an index, and remove, which allows you to remove an item by its index. So as we said, data is stored in a hash table. The keys to the hash table are going to be integers, and they're going to start at 0 and go to the length of the array. And the values can be anything we want. Here they're integers, but when we implement it, we're going to store strings. So it's up to you for what the value can be. The length is just going to be the standard length property. Here it's 6, or 0 through 5. So when we get an item by its index, we want to return that item, but it doesn't change the actual array itself, we just return the value. We can see here we have an array with length 6 with these items. This is the representation of our hash table, which is the array's data. If you try to get an item outside of the index, here we're going to return undefined, which is a JavaScript standard, but it will be whatever the nil or empty value is for your language. With push, we add an item to the end, and this should be in constant time. So we call array.push, then we add this item to the end. We update our length to 7. We set the 6th item to 10, as we see here in the array. We also saw that we updated the indexes. So instead of going from 0 to 5, it now goes 0 to 6. This happens in constant time because we just added one new index at the end without changing any other items. When we call pop, we remove the last item. So here we pop 10, and then we also return it to the user. This takes O of 1 constant time. So we removed it from our hash table, no other indexes changed, so now it's gone. We also updated our array length to be 6. When we insert an item, we use the index that we want to insert at and the value. This is going to operate in O of n time, linear time, and that's because we also need to update the indexes. So we're adding 10 to index 4. You see here, it now takes the 4th index, so we had to update the 2 items after it to have 5 and 6 as their index value. So in the worst case, if you inserted at the beginning or prepended, you would need to update all n items, incrementing their index forward. So this is why it takes O of n linear time. And finally, to remove an item, we just remove it by index. We also return it to the user. So after it's removed, we need to update our array length. Here we went from 7 to 6. And then all the items that came after it in the array must have their indexes decremented in order to maintain the correct indexing. And now we're ready to implement our dynamic array by using an object. We start with the constructor, where we initialize the length to 0, and also initialize the hash table that is going to store the array's data. Then, to implement the get method, we simply return an item from the hash table by its key, and the keys are going to be the indexes. When we push an item, we add it to the end of the array. This is going to take the key that is past the final item in our hash table. Since the hash table is zero-based indexing, the final item is actually at length -1. So the new final item, the one we're pushing, will be added at the this.length index. Then we need to increment our length, showing we added another item. And then finally, we'll return the length to indicate that we've added the new item to our array. When we pop an item, we remove it from the end of the array, which corresponds to the largest index in the hash table. So first, we store the popped item in a variable by accessing it as this.length -1. Then we remove the reference to it in the hash table by calling delete at this index. Since we removed an item, we need to decrement the length. And finally, we return the popped item that we stored in a variable. When we insert an item, we specify the index that we want it to be located at and the item itself. First, we need to increment the length. This opens up a new spot for the item. So since we have an empty spot at the end, we start at the end and then move every item forward by 1. So starting at the final item, we grab the one that was before it and move it forward. This is how we update all the items' indexes. We don't start at the index itself because then we would override the data as we move forward, so we need to take advantage of this empty spot at the end. So start at the end and go backwards. Then, since all the items have been moved, we can override whatever was at the index with our current item, and now it's inserted. And then finally, we return the length indicating we've added a new item. To remove an item, we specify the index for the item that we want to delete. We start by storing this item in a variable to maintain reference to it. Now, we need to re-index all the items. Since now the empty spot is going to be in the middle of the array, we're going to start here and then shift all the items backwards. So now we've actually overridden the item we want to remove. Since we started at the index, we took the item after it and then stored it in that index's spot. So now the item is no longer referenced. This also means there's going to be an empty spot at the end of the array since we shifted them backwards. Since all the items have been moved, we can simply just delete this last spot. We also need to decrement the length, indicating the item is not there. And finally, we return the item that was removed. And we should note that the for loops in both the insert and the remove method are how we're re-indexing the array. This is where that O of n linear time is coming from, because we must update all the items' indexes, or in the worst case, if we add an item at the beginning, or remove an item from the beginning, we must shift all the other items. This is why we can't get anything better than O of n linear time for these two methods. However, for pop and push, because we're working at the end, we're just updating one item, so these will always be constant time. And now we're ready to run our tests. We initially add 8 items and have a length of 8. Then we pop 2 off the end, we see those are gone, and we have a length of 6. Then we insert the exclamation mark and the word custom, as we see here. And then finally, we remove world and insert friends. And that's our array implementation.